Our moderator and presenter, one of our presenters is David Eisenberg, and he'll be introducing himself and the other two presenters, Motts Myhrman, who has been a leader in Straw Bale Construction for a long time now, and Joe Sillins, who is a new leader in Straw Bale Construction, and he'll be sharing new examples. So David, take it away.
All right, well, thank you, Paula. I'm going to go ahead and share my screen. So let me first say something about Motts Myhrman, who with his partner Judy Knox are often referred to as the godparents of the Straw Bale revival. And it was through Motts and Judy that I got involved back in 1992, I believe it was. And there are, as we were talking about earlier before the call, there are a million straw bale stories, and we're only going to tell you a few of them. But one of the really exciting things is that straw and other biogenic materials are moving to the center of climate solutions for the built environment. And it's really extraordinary what's happening. So, and Joe is going to, so Motts will give us the sort of pre-history of the Straw Bale revival. I'll talk about the revival and a number of the things that happened, a little bit of information about straw bale and resources and what's happening now. And then Joe will talk about some of his projects. So I think we should get started. So Motts, are you ready to take it away?
Yes, sir. We're going to start off our presentation with my slanted perception of the pre-revival history of building with bales. Any bale building must start with a baler. By the 1870s, stationary devices like this 2 horsepower, look for them, baler in Nebraska were widely available. However, you had to bring the straw or the hay to the baler. This image sets the scene for the planet's oldest known bale building. I'm going to let you read this by yourself. You should be about reaching the end now, I think. At least make sure you read the last 4 lines. Okay, David. In plain English, the cows ate the school. Jumping ahead now to 1903, here's a classic load-bearing Nebraska-style house where the bales carry all the way to the roof and of any snow load. Down in the lower right corner, by contrast, here's a wooden post and beam structure where the framework carries all the load. These exits are the driveways into the 5 houses in Pbir, Nebraska. A little Nebraska humor. Here's a Sandhills house under construction with load-bearing bales. And here's what the Martin home looked like when they sold it to the Monharts, 1925. You see the proud owners, Minnie and Joe, after they had fixed it up inside and out. And here's what it looked like in the early 1990s. There in Arthur, very close to the Monhart house, the parishioners took the clue from the Monharts and built Pilgrim Holiness Church in 1928. This church is the largest bale building in the Sandhills. It has load-bearing bale walls and was originally plastered with what they called gumbo mud. Here's how it looked in the early 90s. In the inside of the church, a window was put in when the original mud plaster was replaced with lime cement plaster. I started calling this a truth window, and that name caught on. Most modern bales indeed have one. After the Sandhills bale building tradition ended here in 1938 with the Scott House, a few isolated buildings popped up here and there around the country. A unique example of this is the Burritt Mansion, 1938, in Huntsville, Alabama, wet and humid and rainy. On the left here, is the Bruner House, built in 1949. And the grocery store, which they took their cue from the Bruner House, the grocery store is a really fine post and beam building there. This is the cover and an article, fascinating book named Shelter, published in 1973. And there was a one-page article on baled hay buildings in the Sandhills by a folklorist named Roger Welch. And this article turned out to play a big role in our story. And in fact, I think without it, the revival of bale buildings might never have happened, without that article. In 1984, architecture student Gary Strang hears about John Hammond's studio. He visits it, writes this article, which includes a mention of Roger Welch's article in Shelter. Then in Gila, New Mexico, Steve McDonald reads this article and 4 years later starts building a post and beam house. At that point, I got wind of Steve's project and decided to drive up from Tucson and check it out. The roof was on and the doors and windows in, but all the bales were still exposed. While spending a few hours with Steve and Nina, from whom I learned about the Fine Home Building article, I had been seriously bitten by what we now call the bale bug. Once back at home, I got a copy of the Fine Home Building article, located Welch's Shelter article, and started gathering what little information existed about the Sandhills bale buildings. In that process, I fortunately met some other bale-bitten folks. This all led to a gathering at which a small group of the bitten, including Bill Steen, shown here, figured out how the Nebraska style of building might be tweaked for modern use. but there was still a lot of unanswered questions. Longevity, spontaneous combustion, rodents, fire, etc. We all agreed that someone should go up to the sandhills as soon as possible to get some answers. It turned out that only my late wife Judy and I were in a position to do that. So a few weeks later, armed with a more recent and more detailed journal article by our guru, Roger Welch, off we went up to and into the sandhills. Many memorable adventures, new friends, and a lot of good information to share. After our second trip to the sandhills the next summer, we returned home fully convinced that the moral of the Three Little Pigs story was not that you shouldn't build your house out of straw. It was that you shouldn't have a pig build your house. Based on that conviction, Judy and I started presumptively calling ourselves Out on Bale Unlimited. And we did a lot of slideshows and sponsored our first workshops. Then in November of 1991, a reporter from the New York Times called us. Her editor had asked her to do a short piece about some unusual building method, and she found us. The eventual lengthy article appeared on the front page of the Living Arts section. It was read all over the world. And believe you me, that led to the proverbial bale being out of the bag. In the late fall of '92, in order to meet the growing need for shared information, Judy and I started publishing a quarterly journal to provide a meeting place for the growing community of baleheads. The revival was now really picking up steam. So here's David to continue the story.
Thanks, Motts. So I had actually seen both of these things. I had a copy of Shelter, and I was a charter subscriber to Fine Home Building. And I remember reading this article about John Hammond's studio, but somehow I didn't get bitten by the bale bug at that point. I hadn't yet been taken by Strawbale, but I had a lot of building experience pre-Strawbale. The structural steel and steel framing house on the left and the structural concrete house in the center at the top were both houses designed by local architect Judith Chafee. The steel one for a woman with severe chemical sensitivities. The concrete house, which used 1,400 yards of concrete for two people to live in part of the year, was built for George Revachol, who invented Benadryl. After that project, I ended up spending 3 years out at Biosphere 2, basically became the troubleshooter on site for the cover, the space frame and glazing systems out there. After that, I started a construction company, a somewhat ill-fated one with my younger brother and another friend, Todd Zellickson. We called it New Paradigm Builders. We were a little ahead of the curve in terms of trying to build non-toxic, environmentally responsible houses, but we were onto something nonetheless. After I shut down New Paradigm Builders, I went to work for a little while for Paul Weiner and Design Build Consultants, and I built the Axelrod house, a rammed earth house that ended up on the cover of the Fine Home Building Houses annual issue. And at that same time, a little group of us started the nonprofit Development Center for Appropriate Technology that I've been involved with ever since. And I ended up meeting Motts and Judy through the Sonoran People's Summit, which was an official precursor event for the Earth Summit in Rio that year. And we became friends around the same time. I met Bill and Athena. And I went to a couple of Motts and Judy's workshops, and I started helping with the workshops, and I started teaching the workshops. And through all of that, it started to become obvious that we needed to figure out how to help people get permits for their straw bale buildings, because although they could build them, they might not be able to do it legally. That led to a whole lot of activities, including going and meeting with the city and county building officials. Motts and I went and we asked them what they needed, and they said they needed numbers. Actually, they said they needed to know something about how strong these walls were. And so we found a graduate student actually in structural engineering at the university, Galen Bouali, his professor, structural engineer, a couple of architects, and with the building officials, we designed a series of structural tests that we carried out with the building officials witnessing them. And based on that, the city county code committee enabled us to start a process of developing a building code. So that was the winter of '93 that I wrote this the first full issue of The Last Straw with real content in it was this winter issue in '93. The next year I wrote an article, Building Codes, Straw Bale Construction and You, which inadvertently turned me into the Straw Bale Codes guy. I wasn't really happy about that, but it turned out to be a good thing. So along the way, we did all kinds of work, and more resources started to develop. Motts and Steve McDonald wrote Build It with Bales. This is actually the second version, which you can see here. You can download it as a PDF file for free on the DCAT website. Bill and Athena and David Bainbridge and I wrote the Straw Bale House book. We got involved in a project up on the Navajo Nation to build a compressed earth block and straw bale house up there. We helped write the little booklet that DOE produced about that. And we started trying to find ways to do more testing. We did thermal testing at Oak Ridge National Lab in Tennessee. We did fire testing in Texas. We tested two full-scale wall panels. One was bales on edge with just earth plaster, which survived the 1 hour test, and bales laid flat with cement lime stucco that got a 2 hour rating. And then there was more testing, seismic testing, out of plane, all kinds of structural testing. People were interested in moisture. Laura Bartels in Colorado came up with these moisture sensors that could be installed in your bale walls and then wired back to a little panel so that you could tell what the moisture content in the walls was near the outside, near the inside, and in the middle of the wall. There was a lot of innovation. But anyway, if you think back to that 1993 article about testing, it just took 20 years. In October of 2013, we succeeded in getting a straw bale appendix approved for the 2015 International residential code, which is the national US residential building code. And at the same time, actually, we had also proposed a light straw clay appendix, and it was approved as well. And you can see on the left in this photo, Mark Aschheim, who's unfortunately no longer with us, a fantastic structural engineer, Martin Hammer, with whom I have done almost a couple of decades of work writing codes, and Laura Bartels standing next to me. That started something. So these are all things that are now in, or one soon to be in, the International Residential Code. So in 2018, we got the tiny house appendix developed and approved. The light straw clay and straw bales appendices went in 2015. In 2021, the Cobb appendix was approved. And just about a month ago, the IRC committee approved the Appendix Y for hemp lime construction, hempcrete. So the 2024 code will have that. Just briefly, Motts mentioned load bearing and post and beam. This sequence on the left is actually one day. And this is the Guadalupe house up near Tempe, up in the Phoenix area, that on the day of the wall raising, we stacked all the bales. We put the roof bearing assembly on, tied it down, put the trusses on, and at the end of the day, we were ready for the roof to be sheathed. We had about 160 people come to that wall raising, which is not exactly a help in terms of productivity, but we had it well planned. And then on the right are some post and beam structures that you can see there's a wide variety of ways to build with other structural systems rather than using the bales as the structure. You can also retrofit buildings. And this is the house that was next door to Motts and Judy's house that they wrapped in bales for insulation and beauty. All kinds of buildings have been built with straw bales now, tens of thousands of them around the world. Schools, a couple of post offices, multi-story buildings, a lot of residences, and many of them are really beautiful. This is a winery in California. And of course, one of the great things about building with bales is they're really sculptural. If you use natural plasters, you can do all sorts of things. You can create some extraordinarily beautiful buildings. And unlike when we were starting out, there are a tremendous number of really good resources and workshops and information available to guide you and help make better choices for how to build, or decisions for how to build. And among those, so one fairly local resource is the Canelo Project. Bill and Athena Steen and their kids. I would take some time and go to this website, the caneloproject.com, and check out their work. It's extraordinary. And you can go down and visit their place, which hopefully is going to be okay. The San Rafael fire that's down near Patagonia is burning towards their place. So fingers crossed. California Straw Building Association, CASBA, also has a lot of great resources. And there's a lot more. So we were talking about the last Straw Journal. It wasn't being published for a while. And then some young people who came out of Auburn, the Rural Studio Project at Auburn University in Alabama, decided to see if they could start publishing The Last Straw again. And they have. And in the first of the new issues, they actually have this long interview with Martin Hammer about building codes and the work we've been doing. So, and also all the old issues of The Last Straw are available on that website for downloading, thelaststraw.org. And what I want to talk about for a few minutes is what's happening now with this recognition of the importance of biomass in buildings, turning buildings into carbon sinks. People are talking a lot about embodied carbon, and they're typically talking about the impacts, the emissions from creating buildings. They're not talking about physically embodied carbon, like carbon molecules in the materials. But my friends Chris Magwood and Bruce King have this brand new book out, Build Beyond Zero, which is fantastic, and I highly recommend it. But Chris has been looking into this issue for quite a while and doing really important research. And he's just been hired by the Rocky Mountain Institute. I don't know how many of you are familiar with the Rocky Mountain Institute. Amory Lovins founded it, but it's a really high-powered organization doing environmental and energy and building work. And Chris is there now helping them understand and roll out a lot of this stuff. This yearbook 2020 on the left, supporting the use of straw in urban and public buildings. This is in Europe. I'll get to some of those buildings in a minute, but I want to just quickly describe this concept because it's really important. People are talking about net zero energy buildings, and people are talking about net zero carbon buildings. But what people are missing is that the embodied impacts of buildings are really important, not just the operating impacts, but what actually goes into building the building and the impacts of all of that. And if you think about a building that's a net zero operating building versus a typical building, you build it, it has a certain level of impact, and then over time, the operating energy increases those impacts, and ultimately the operations. This is for a high performance building, so it's saying 60% for material and 40% for operations. But the critical thing is that by 2050, the impacts from the building itself, not the operations, are still larger. And the timing of that is really critical because basically these impacts, the carbon that goes into the atmosphere, it stays there over time. So one of the things that people do in order to get to net zero operating energy is they increase the embodied energy by adding things like foam insulation, all kinds of higher tech materials and systems typically. And if they can't get to net zero any other way, they add renewable energy systems, which also increase the immediate impact of the building. So it's really important to pay attention to what you're building with and what the impacts are. And Chris Magwood and his organization Builders for Climate Action created this incredible tool. It's called BEAM, Building Emissions Accounting for Materials Carbon Estimating Tool. And it has information about the actual climate impact of all kinds of building materials. But this graphic is for insulation. And you can see up at the top, that's extruded polystyrene foam, and it's really large. And down at the bottom, there's hemp fiber, cellulose, wood fiber bat, hempcrete, wood fiber board, and at the very bottom, straw bale, these are actually building materials that store carbon, more carbon than it, by far than it takes to produce them. And what this tool lets you do is actually calculate all these different materials for the quantities that you would use in a given building. And so you can see what the impact is going to be and how it's affected by your material choices. And the good news is you can actually get to carbon positive buildings by careful design, material substitution, etc. So this is really big and it's starting to get a lot of attention. So Chris Magwood created the Endeavor Center in Canada. It was a school, basically. They built all these buildings, most of them straw bale, some hemp, a lot of other biogenic materials in their buildings. And Chris studied that stuff. But here, I'm just going to show you quickly a sample of what's happening in Europe. So here are prefabricated straw bale panels in this building. This is a retrofit. They insulated this building with straw insulation. That one is in the Netherlands. This one's in the UK, more prefab straw bale panels. More of these at the University of Nottingham in the UK. Here's one in East Anglia in the UK, where they used all kinds of things, timber, thatch, straw panels, all kinds of biogenic materials in this building. Here's another one with prefab straw bale panels. They're building big buildings, and this is really taking off in Europe. And one of the things that's just started to happen is the federal government is finally recognizing this. And at the end of last year, the Department of Energy announced they were investing $45 million in these kinds of technologies. So this stuff is happening. And if you think about straw bale construction from its humble beginnings out there in the sandhills of Nebraska to where we are now, it's quite extraordinary and encouraging. And now I'm going to turn this over to Joe. And Joe, do you need to, do I need to stop sharing, or how do we do this?
If you want to just keep sharing, and then I could just, say next.
Okay.
Wouldn't mind advancing the slides for me.
Yeah,
great.
no problem.
Thanks, David. I'd like to thank Sustainable Tucson for the invitation to present this evening, and I want to thank Motts and David for working with me on this one. It was really a privilege to be sharing the stage with these really like powerhouses in the straw bale world, hearing stories and kind of collaborating. And what I really want to know is, when do I really get to hear the real good, juicy gossip dirt on all the straw bale and natural building characters that I know? Sign me up for that.
Yeah, we'll have to go to the bar or something.
All right, it's a deal. It's a deal. But really, I think we don't realize how good we have it these days in terms of straw bale building and the groundwork that has been laid until we hear some of these stories and kind of see the details and all the work and the testing that's been done. So my hats off to you all and all the others who have come before. So yeah, Tierra Buena Home and Garden is my company. Actually, if you can just go back to the last one, that photo is from the very, very beginning, right around the same time I started the business, a few fewer gray hairs and a little bit more of it. But that was about in the fall of 2016. That was a clay floor that I was installing in my first big natural building project, my casita. And then there's some contact info on the right side of the screen, and then that's coming at the end of the presentation as well. So I post photos pretty frequently to social media of current projects, and so you can also reach me via email. Next, please. And so Tucson-based alternative building consultant specializing in earthen and straw bale construction, smart sized, small and tiny homes, creative salvage and reuse, and also integrating composting toilets and water harvesting systems into structures. Next, please. And in terms of services, offer conceptual and design development, owner builder assistance. In the state of Arizona, you can build your own home as the owner without needing to be a general contractor. So I provide resources to people wishing to build, and also provide workshops and educational opportunities. At the bottom there, you can see a workshop I co-hosted with Dave Moschel, who's a longtime Adobe builder here in Southern Arizona, basically getting an owner builder trained in Adobe block laying, and then kind of turning over the reins to her and a group of her friends and other volunteers who have been continuing the erection of that structure. Next slide, please. And I did present on this project. I know I'm supposed to be talking about current work, but you know, we're talking about history in this presentation. And so this was kind of a critical piece of my own path in terms of natural building and straw bale construction. And this was kind of what really launched me on my current trajectory, you might say. And this was a casita, or a guest quarters, built here in Tucson in Midtown. Started in January of 2015, and then was far enough along in the fall of 2016 where I could move into the structure and start my business, because it was a strong indication that I enjoyed this kind of work and had somewhat of an knack for it, and was permitted under that 2015 International Residential Code Appendix that David mentioned, load-bearing straw bale, and had an architect, Himit Khalsa Singh, who's currently teaching at Pima Community College, who helped me with the plans and the structural design. You can kind of see on the photo on the top left, it's just an open floor plan. The kitchenette is at the top left corner, kind of open living space in the middle. And then on the right side of that floor plan, there's a little bathroom, closet, and then a loft above for the bed. You can kind of see the bird's eye view in that photo on the right. A lot of natural light, recycled and salvaged materials, from cabinets to trim, and water harvesting and a composting toilet. And then at the bottom left, you can kind of see the casita there from the outside while it was still being built. Next, please. And then much more recently, so this is in the spring of 2020, I was brought in to assist with this project. This is also a load-bearing straw bale, about 1,200 square feet. And this was permitted with the 2018 residential code. And so the owner builders are a young family, couple with 2 children. And so they wanted a 3-bedroom, 2-bath with room enough to expand. And this particular project was designed by Ray Clamens of Natural Building Works, who's based out of Tucson and does educational workshops and design as well. And my role was just to kind of assist with construction details, coordination, education, and on-site assistance. Kind of looking at the project here, you can see it's a pretty compact floor plan with the kids' bedrooms on the left. Floor plan, open space in the middle for living room and kitchen, main bedroom up above, and then bathroom in the top right corner. And then you can kind of see a progress photo there after the roof had gone on, and after a particularly wet summer here last year in Tucson. Next slide, please. And some progress shots. So earthen plasters, we used soil that was sourced on site as a real strong dark clay. And so you can see the clay plaster on the outside of that top right photo as it was going on. You can see on the bottom left corner there, the engineered trusses that were used to give nice vaulted ceilings. It'll provide a really nice kind of airy feeling in the structure. And then you can see on the right there, some framing going in for the kids' bedrooms. There's going to be like a play loft up above there. And people, when they set out to build a straw bale or a natural home or a custom home, there's always certain things like, they don't want to just have, the same old house that everybody else has. So these particular clients are going to have like these really intricate geometric tile mosaic floors and window details. And they both studied as geologists. So there'll be fun kind of veins of different minerals running through the exterior plasters and the interior as well. And, I was brought in to get the project far enough along to where the clients could kind of take it and run with it with the trades that they're more comfortable with. So I don't have any more, I've kind of stepped away from the project and I don't have any more updated progress photos, but that's an ongoing build as well here in Tucson. And the next slide. And then that brings me to another ongoing build for an owner builder up in the Verde Valley in Camp Verde, which is about 2 hours north of Phoenix. This is just over 1,000 square feet, 2-bedroom, 1-bath. And I collaborated with the owner to develop the plans and the blueprints. You can kind of see, it didn't really come through very well, the floor plan, but the leftmost image, it's kind of an L-shaped building that was really tucked into the site to minimize the number of trees that needed to be taken out. Client really wanted to preserve on-site vegetation. There's a lot of beautiful ash trees there right down near West Clear Creek. And so there's kind of the north side of the building in that right photo with lots of windows, lots of natural light. And next slide, please. And then there's an interior accent wall. It's made with compressed earth block. That's in the background of that top left picture. Some really nice sculptural touches like arched windows, and then on the bottom there you can see kind of some site context there with the cottonwoods and the ash trees in the background. An earthen plaster in the process of going on the exterior of that house. We were able to find some really strong red clay that came out of a road cut in Sedona, and so there's always sourcing of materials. David talked about the embedded energy that comes along with these different materials, and you can really save a lot of embodied carbon, but you end up doing a little bit more legwork in terms of sourcing and testing materials. And so we were able to find this clay after much searching, and it's going to be a really, really beautiful kind of accent for certain parts of the structure. Next slide, please. And not so much straw bale, but poured clay. And so we talked about testing and experimentation and exciting new building methods and materials. And so I wanted to get my own hands dirty, so to speak, and try something new. And so the real spark behind this, or the impetus behind this structure, was to build with clay and do so in a way that I could save labor. Basically, you making adobes, you make the blocks and then you dry the blocks and then you kind of move them back and forth to dry the different sides, and then you take them over to the building site and you lay them. And so this was the goal was to, by pouring the mix right in place on the wall, to reduce the amount of labor that is involved. And I'm not quite sure that I succeeded in that goal. You can kind of see, so top photo on the left is some test blocks. I tested a number of different materials, stabilizing ingredients, cement, lime, just kind of raw earth and gypsum to check their properties, and a real sophisticated testing apparatus. I took a hammer to all those blocks and stomped them and threw them against things. At the top right, you can see some of the forms that have been filled with the wet mix, and waiting to set up enough to where I could strip the forms off and allow them to continue drying. Bottom right shows some blocks on the wall that were probably about a few days old at this point. And there's a model, SketchUp model of the structure there on the bottom left that I made to help kind of envision the whole process and really assist with the construction. Next slide, please. And so here's some more recent photos, utilizing a lot of salvaged and reclaimed materials like a lot of my other projects. At the top right, you can see some nice old doors that came out of probably a school building or maybe a church that I was able to score at Originate Natural Building Materials here in Tucson. Scored some beautiful beams from a local builder who was getting rid of a bunch of materials in his yard. Bottom right corner, you can kind of see the finished material in the room before I did any flooring, with the wood planks in the ceiling and the brown walls. It really ended up looking a little bit more like a cave than I really had preferred. And so on the leftmost photo, you can see after a lime wash has been applied and the floor is installed, it's ready for use as a room or a shed or a workshop of some sort, with a little bit of a loft for storage in the background. And next slide, please. So just kind of looking ahead, my business has really morphed into doing more consulting and technical assistance and design, kind of changing from the earlier days where it was a lot of on-site assistance and grunt labor, which was great for learning and for getting some good projects under my belt. But I'm not getting any younger, and actually I can have a greater impact by doing more design and kind of some of those elements or tasks coming down the pipeline, looking at doing an owner builder academy or a training program just to provide more assistance to people who are interested in building their own home. There is surprisingly quite a bit that goes into it, or not surprisingly. And then also, maybe sometime here in the next year or two, building some of my own projects once the building material inflation and everything kind of calms down. So that's it for me. Do you guys want to say anything to launch the question and answer section?
No, thanks, Joe. Good to see your work and its evolution, and it's always good to hear Motts retelling some of that history that was really important early on and continues to be. So yeah, let's I could stop screen sharing and we can entertain some questions. I don't know whether I see there have been a few things in the chat.
There's a question from Ben Need in the chat.
Right. So, Joe, you're this one. Can you see the chat, Joe?
Yeah, I can. So beyond permitting and land acquisition, what would be the cost of building that 450 square foot casita? So that's a good question. It depends, of course, on detailing. As an owner builder, there's a whole spectrum of how much work you're engaged in, and how you can find labor. I did have a piece in the Mother Earth Journal, I think it was last spring, actually, came out basically sharing my project, the Casita project that I shared at the beginning, and it was the title was like Straw Bale guest house on the cheap. And so I think my costs were around $30,000, including permitting, including design. I think it came out to about $70 a square foot, but that's doing all the labor myself. It's bringing in friends in the trades and everything to help out, and really being quite frugal and Spartan in a lot of the fixtures and installations and cabinets and things. So, as an owner builder, you do get to save. You don't necessarily. You can bring in licensed contractors. You can scrounge materials. You can find people however you can, and you don't have to pay the overhead for a general contractor. So it certainly does save money. The last couple of years have been really bad in terms of inflation for building materials and also labor, just because it's really hard to find people right now, licensed, unlicensed. So, I had information from, and I'm fairly new to this, so, I don't have like a long portfolio of past projects. I know, so Dave Moschel, the Adobe builder that I showed a photo of early in the presentation. I don't know if I should name names or name numbers, but he told me a while back that as an owner builder, this was 2 years ago, if you're really conscientious, you could build a Adobe house, like modestly furnished, for $120 to $130 per square foot, which I would imagine straw bale would be comparable, just by virtue of materials and labor inputs. But now we're probably looking at more in the $200 per square foot range, based on inflation. And so it's kind of a long answer to your question there, but it's hard, it's kind of tough one. There's no straightforward answer there.
So I see this one from Katie thanking us and asking if someone wanted to go into the field of natural building, should they study architecture or structural engineering? Yes. I think potentially, architecture is, one of the really interesting things that's happened over these last, say, 10 years, when we've done much of this work of trying to get these alternative materials into the building code, is how challenging it is from in terms of the structural concerns about seismic, wind, et cetera. And really, because these are non-industrial materials, so they're not, as uniform, or consistent as industrial materials. And, one of the, very early on, one of the ways we tried to kind of turn that around with building officials was talking about wood, as a building material, and essentially pointing out that if wood were introduced today, as a new building material, it would be nearly impossible to get it into the building code. Because you think about it, there's hundreds of species. The strength and durability are dependent on the species. The strength's dependent on things like the orientation of the grain and the size and frequency and location of knots. It rots, it burns, insects like to eat it, it's dimensionally unstable, et cetera, et cetera. And it's our material of choice for residential construction, in this country, and we build millions of buildings a year using it. and the difference between wood and some of these other materials is that billions and billions and billions of dollars have been invested in turning that natural material into a more industrial material. And there aren't similar subsidies for a lot of these other materials because there's not an industry behind them. And so finding structural engineers who are both creative and courageous enough to engage, in designing these materials has been a bit of a challenge. But right now there's a structural engineer, Anthony Dente in Berkeley, who did the work developing the seismic and other structural provisions for the Cobb Appendix and for the new hempcrete appendix. And it's really great when you have a structural engineer who's savvy, who's really open-minded, creative, and has the courage to keep pushing the envelope to figure out, what's doable, what's safe, where the boundaries need to be, etc. And and as far as architecture, depends on where you go. I mean, I started out in architecture at the U of A here in the late 60s, and it was a terrible time to be in architecture. It was the brutalist huge concrete buildings and urban renewal. We called it urban removal, where they were tearing down the hearts of all these beautiful buildings in the middle of cities and building these community centers. Anyway, I left architecture school after a year and a half and started building things. And so, I think there are some really good architecture schools. And in fact, at the U of A now, there are some really good people like Mary Harden, fantastic at the U of A in the architecture college. And there are lots of others.
Add on to that, if you think you'd like to go into natural building, get involved on some builds, if there's some workshops or projects, going up locally, or other opportunities. As David mentioned, Canelo Project down in southeastern Arizona is a great resource, and they have a variety of different trainings and tours that they can lead you through. Kind of might be a lower financial bar, rather than going out for one of those degrees. But certainly, I think, the work that David has highlighted here tonight shows really the value of more detailed study, which does take a higher level of academic instruction, certainly for some of those forms of testing. I do see Stephen with his hand up as well for a little while.
I had two questions. So one is sourcing the bales without having to truck them from a long distance. Is it a real problem getting good quality bales? Because I imagine some places like in Alabama, I used to bale hay for a living when I was a kid, and it can vary widely what condition that hay's in when you bale it.
Yeah.
So I was curious about that. And the second question I had was, how do you install the electrical and plumbing on these houses, the straw bale walls?
So, I don't know, Joe, you want to talk about where you get your bales?
Yeah, sure. Typically, they come from local feed stores. I have tried to get bales direct from farmers. Actually, I think I may have worked on a project with bales from Eloy once. It just kind of depends, up in the Verde Valley, the project that we're working on right now. We had some bales lined up from a farmer, a mile down the road, and then his brother sold the bales out from under us, and we ended up having to get a truckload of bales from California, I think, actually. So it just kind of depends, no two baling machines are the same, or no two sources. So there are certain considerations, like if you're sizing a building where you have all your infrastructure in, like your foundation and your post, if it's an infill or whatnot, you definitely want to make sure the bales that you're buying match the bales that you've dimensioned your stuff off of. So it has typically, in recent times, been coming from local feed stores. And in terms of electrical and plumbing, the thick nature of earthen plasters or lime plasters typically meets code for coverage over wiring. So, I've been using the gray UF wire for running it just on the surface of the bales. You basically just tuck it into underneath the strings. I know some people run it in conduit, so there's really a variety of different ways. In terms of plumbing, it could come up from your foundation. It could penetrate. I guess I am of the mindset to isolate water lines from straw bales. So I typically try not to, you can integrate them into interior frame walls. You can pop them up through the slab or, the flooring, whatever that might look like. So there's a number of different ways to do it.
Thank you.
We've got some others in the chat. Carol's asking, are there any current Tucson area builds to get involved with?
I'm not,
Oh, go ahead, David.
I was just going to say, I'm not sure right now.
I did drop a message in the chat. If you visit my website, you can sign up for a newsletter, and I'll inform you of any upcoming builds. I mentioned this consulting transition. I'm helping out with design for a set of plans for a small straw bale casita here in Tucson that might go to the building phase coming up this fall with some owner builders. There might be another one out in Cochise County coming up. So I'll certainly keep people tuned. And then also Natural Building Works is another, Ray Clemens, who I mentioned earlier, leads workshops around rammed earth and other natural building techniques. So I'm not current on his workshop offerings, but Natural Building Works, they do have a website you can check out and sign up through there.
Yeah, one other thing I'd add is that the Canelo project, it is worth going down there to visit when they give tours periodically, but they do workshops. They do straw bale workshops, plastering workshops. They're really set up to do, really good workshops, and they've just built so much. And boy, if you want to see examples of just a wide range of how to use tools, materials, different ways to build, it's all down there.
And they always have really good food too at their training. So I'm not sure about the tours, but
yeah,
working up an appetite.
When we were writing the Straw Bale House book back in 93, I guess, or 92, 93, whenever that was, I used to go down there and spend like 3 or 4 days at a time. And I was never fed better in my entire life.
Don't let Pat hear you say that.
She wouldn't mind.
I'm sure.
So I've got a question. My interest is in figuring out how we go back and retrofit our old homes. And I'm considering how to deal with some 1950s triplexes I have. And it seems like it would be similar to the old home that you did, Motts, But the problem is that the straw bales are so big that they really would take up, dramatically increase the size of the building. And there's just not enough room really to do it. Is there any options available?
Well, there are some interesting materials that are being developed, which are, you know, different kinds of bio-based. Some of them are straw, but there are a lot of sheathing materials, some of which are insulating materials that are sort of coming onto the market. And, you know, one of the things, so are those buildings, are they concrete block?
Yeah, CMU block.
Right. And so one of the things about block buildings is that they have thermal mass, which is good. Where you want the insulation is on the outside,
Exactly.
not the inside. A lot of houses got built in Tucson back in the 60s and 70s that were slump block or concrete block, where they furred out on the inside and put a little bit of fiberglass insulation. But the problem is that thermal mass is just sitting out there in the weather, getting hot or getting cold, and
Right.
either radiating heat in or sucking heat out. You know, whereas if you put the same amount of insulation on the outside of that thermal mass, you get a huge benefit. And so, you know, over the years, I've had many conversations with people talking about things like, well, could you make smaller bales? And people are actually, you know, some people are doing that. Or could you, you know, do something else? But the other advantage of potentially of doing some of these things on the exterior is that a lot of these old buildings need their plumbing and electrical upgraded. And you could do that on the exterior, you know, go through the wall to, you know, to the inside and have it be within, you know, within that added layer, you know, and then plastered on the outside.
Well, of course, I'm trying to do exactly that, and finding anybody who will do the work has become an insurmountable problem so far.
Yeah. Well, I don't have a solution to that one, or at least not yet. Motts, do you have anything you want to chime in about?
Well, there are a couple of things perhaps. Dropping back to, you know, getting funding to do research and all that sort of thing on materials. So many of the materials that are built with, they're proprietary in the sense of, you know, the people who are behind it stand to make a lot of money out of getting testing done and approved. And when you get to something like straw bale, you know, nobody owns it, and nobody's going to specifically, you know, make a lot of money by getting certain kind of approval for the material. So it certainly made it difficult for us to be able to do that testing. And a lot of it had to be donated, or you know, done with the university, getting students involved. It really made it tough to do that. As far as Trace's thing with the thickness of the bales, depending on who you believe, you know, the R value of bale straw, it can vary a lot, of course, depending on how dense the bales are and so forth. But I think California, they've talked about, is it 1.5 R per inch, David, something on that?
I forget what we changed it a little bit in the 2021 IRC, I think. But yeah, it's, you know, I'd have to look it up.
Yeah, but it's on that order, certainly. And that means since it's not a huge amount per inch, that's not a problem if you're going to build with bales. You're getting such a huge thickness of it that you can get phenomenal insulation. But if you're trying to cut it down and like split a two-string bale, which is about 18 inches wide, split it in half, which I've seen people do with a chainsaw, you can end up with the slabs that are, 8 or 9 inches thick, and they're tricky to handle. And 9 inches times 1.5 R, let's say, you may be getting R15, R16, and that's not too bad, but it's a lot of work
Right.
to get that amount that way.
Yeah. Yeah. I mean, it's, that one slide I showed that had the graph of different insulation materials and their impact. I've been on a long-standing sort of campaign against plastic foam insulation, in part because of its very large climate impact, but also because all of it has really toxic flame retardants in it. And that could be a whole other long conversation. But the the reality is the energy code actually treats thermal mass walls differently than just pure insulation walls. And when you have a combination of mass and insulation, you actually finally it's beginning to be recognized that less insulation on the outside of a mass wall is necessary. You don't need a lot of insulation on the outside of a mass wall, and especially not in a climate like this one. It varies, obviously, where you are. The other thing that Motts brought up about funding for research, years ago, we got to do a congressional briefing on Straw Bale Construction in DC, which was fun. But one of the things I included in my presentation was that in all the national laboratories, there's a program that's of grants. They're called SBIR grants, Small Business Innovation Research Grants. And in order to qualify for one of those grants, you have to be a for-profit entity with a proprietary, material, system, chemical, whatever it is. So if you're a public benefit organization like a nonprofit, and if you have something that's in the public domain, you're not eligible to apply for those grants, which is crazy because it's public money in public facilities with public employees, who are doing all the work. I'm fine with the SBIR program, but I was promoting it at that congressional briefing, a parallel program, which I called the Pbir grant system, which would be public benefit, not peanut butter, public benefit innovation research grants. That would basically be for things that are in the public domain, and that, nonprofit or government entities, could basically do the same, get funding to partner, with the national labs for R&D, and developing the things that we need. So far I haven't had success. I've been pushing that idea up into view for a couple of decades, but I'm not likely to stop pushing that idea.
I can interject something here too, in terms of insulation materials, Trace. You might look into wood fiberboard insulation. There is a supplier, 475.com. I think you have to spell it all out. They sell a variety of different products for high performance buildings with a real focus on, low carbon, low toxicity. And so they have a variety of membranes. They have a variety of fiber boards. And so, I can't imagine that those are cheap right now, the freight and everything, depending on where they're coming from. But there has been, I was talking with some other local natural builders, and they were talking about prefabricating like straw wall panels, like David was showing, and fiber boards. Apparently, there's a guy out of back east, Jacob Rakuzen, I think, New Frameworks has been making a lot of the materials, and I guess is fairly open source with it too. So, if we could find somebody with the warehouse space and the capacity here locally to build some of this stuff, it could be an exciting kind of incubator business if there's a demand for it.
Maybe we could make insulation out of buffalo grass.
I've got a specific idea for that.
There's actually a guy here in town who's been involved in buffalo grass eradication for years and has been accumulating it and using it in adobes, basically. Interesting guy.
So I've got a question also. There were quite a number of building materials mentioned besides the straw bale. Compressed earth block, I don't know if that's the same or different from rammed earth. Hempcrete, poured clay, adobe block. How would one decide what kinds of materials to use if you were inclined to be building a house or working with a builder or someone like Joe on this?
Well, you could ask Joe. but
are there features of each of these that would help one decide or make the choice?
Yeah, and in fact, here's a source, one of Chris Magwood's books, Making Better Buildings. And Chris goes into all kinds of alternative materials and looking at them, in terms of their life cycle impacts and their characteristics, etc. There are differences between, compressed earth blocks and rammed earth and adobe, puddled earth, poured cast earth. And some of those differences have to do with what things might be added to the soil mix. But it really, in part, it depends on where you are and what's available and what and who's available often as well.
Mhm. I saw that Joe responded to one of Barb's questions, but I think there was another piece to it about heated floors.
Yeah. I can, I guess, just to kind of tack on to what David was mentioning about materials, definitely who's around, competencies for different people to build that home. Oftentimes it's really a matter of what material speaks to you. People come and they've experienced one material or another and they really fell in love with it. So, clay, straw, all these materials are very earthy and tactile, and they can lend themselves to beautiful rounded corners and sculptural elements. And so I guess, if you talk to the straw bale guys, they're going to tell you to build with straw bale, or the adobe guys, and they'll tell you to build, or gals, and they'll tell you to build with adobe. And there's the insulation strategies, and then there's mass strategies, and David was just talking a little bit about appropriate strategies for this climate. Some people say you want a nice, well-insulated envelope with a lot of thermal mass on the inside. And so that might be, straw bale with something like an insulated earthen floor, or a nice like trome wall or something. So it just really, really depends. Or, there's a lot of, I guess, more modern buildings with a lot of glass, and so it just really depends. The sky's the limit, and there's price is a certain consideration, but there's different ways of going about working within a budget. I haven't done a lot of heated floors, the radiant heat systems. I know, I think people talk about doing them a little bit more for like grid tied homes, so homes within an electrical grid, just if they need to heat that water. You can use solar water heating to meet the needs. It's not necessarily any different installing it in a natural home than it is in a conventional home.
David,
Sharon, yeah, go ahead, Sharon.
would you be able to tell the author again on that Making Better Buildings?
Yes.
You mentioned it quickly.
Yes, sorry, it's Chris Magwood, Magwood. He's
Thanks.
a lot of really good books. He's the guy who also co-authored with Bruce King that new book, Building Beyond Zero. And he's also written a few books on straw bale construction, which are excellent, and on other things, on sustainable design. And he's a brilliant guy.
Thanks.
Yeah.
I was also wondering if about I've heard that in Cochise County, you have to have a septic first and have it gone through permitting before you can do anything. And I was hoping to do something totally off grid with like a compost toilet. So I'm not sure if I'm getting correct information there or not.
The best thing to do is actually, so some of these things you can find out with the building department. Sometimes there are other departments, but what I have long recommended is that people actually go, and ask. And if you have something that you want to do and you've got some good supportive, literature or information about it, you can take that with you. But basically, so many times, it can go either way. One thing you don't want to do is go expecting a fight, because typically if that's your attitude, you'll find one there. But, the reality is, if you can, basically say, here's what I want to do. What do I have to do? Can I do this? Oftentimes you find people who are willing, to help you figure it out. And sometimes, there are a bunch of stories over the years of, a friend of mine related this to me, that they followed all this advice that I had written out years ago about how to go, talk to a building official about straw bale construction. And they gathered all the books and all the resources, had all their arguments, and they went. And it turned out, I think the building official was the brother of one of the straw bale architects in California, who knew all about it and was kind of waiting finally for someone to come in and want to do a straw bale project. And I met a woman in Maryland once, about 8 or 9 years ago, who told me that she got her permit because I had given a talk in Berlin, Maryland, like, I don't know, years before that the building official attended. And when she went in with all its stuff ready, the building official she said, I want to build a straw bale house. And the building official lit up and he said, really? Finally, this guy came. A guy named David Eisenberg came years ago and he gave this presentation, and I've been waiting all these years for somebody to come in and want to build a straw bale house. It's way different now than it used to be. You still run into, it's the whole spectrum of, human types, capacities, etc. But the best thing is just to go and ask, just say, this is what I want to do. I've heard this, is that true? And, might as well go have the conversation with the person who can tell you for sure, what the situation is.
Okay.
I did drop a comment in the chat, Barb, in response to your question. I believe it's statewide through the Arizona Department of Environmental Quality that you can install an alternative septic in conjunction with a composting toilet, kitchen gray water system, and a grease trap that you basically just install a kind of a reduced size leach field, and you don't have to install the septic tank. As long as you kind of meet these other guidelines and you satisfy whatever requirements for infiltration and whatnot. I believe that's statewide. I know I've seen those systems installed in Pima County, and I'm looking at Coconino County website. It looks like they've got stuff there. So I believe that's the case for Cochise as well.
Right, great.
I think you're probably right, Joe, because Watershed Management Group here did a number of composting toilet experiments under the guidance of this ADEQ. So I think it's actually been approved statewide. If we've got just a couple of minutes, I'd like to ask about two more weird materials. One, David, you turned me on to is rock wool insulation, the board as opposed to the bat. And the other is, for years I've heard about people who take straw or shredded newspapers or whatever, soak it, inoculate it with mycorrhizal fungi, and let that turn the whole thing into a solid block. And it's a decent insulation. Do you know anything about that one?
There's a company called, I think it's Ecovative, that has been, working on a lot of different mycelium-based products. So far, I don't think they've really gone into insulation, but I'm sure there are others who are, who are working on that. And yeah, Rockwell, there are a bunch of these different materials that, that are definitely worth, investigating. I know it's been a while since I actually sat down and did a bunch of my own research because I haven't needed to. And then if you have friends like Chris Magwood, what, I mean, why would you do that?
I've got a comment here in terms of a possibility, and it'd be interesting to see what reaction we would get. And that's this bi-block thing, the blocks that are made by heating and compressing plastic bottles, particularly the ones that can't be recycled because there's no market for them. And there are a couple of companies that are making these blocks, and they're making them in the way that they key together. And Steve Kozaczyk, Ward 6, has been really working on that, and they're hoping to do a couple of small projects soon. I haven't gone to the trouble of trying to find out a whole lot about it. I did have some questions if you're going to build a structure to live in, sort of what the possibility of off-gassing might be or might not be in terms of the materials. So there are some questions, but it looks like it could be a way to make beneficial use out of some plastic that just is going to end up in the landfill, very definitely. So I'll just throw that out.
Steve K has a little piece about that in his latest newsletter that came
Yes.
out yesterday.
Yeah.
And if anyone wanted to read it and doesn't already get his newsletter, you can go to the Ward 6 website and probably find it there, find a link to it there.
Ben, did you have something you wanted to?
Just an observation. I found out just the other day, the house that I rent here in Tucson is made of something called Mikey block, which was a commercial, I think it's recycled foam mixed with cement, molded into blocks. And our house is insulated beautifully. And it's kind of nice to know that that foam, you know, just didn't end up rotting in a landfill someplace. The structure seems pretty good, should be lasting for quite a few years.
Yeah, there are, I think that's one of a building, a class of building systems, insulated concrete forms, ICFs, that basically they're typically foam, like if you think about a concrete block that's hollow, you know, but it's foam instead of, or foam mixed with cement, but then you pour in not every cell, you know, but maybe every third one, maybe there's rebar, and you grout that with cement, and then you can insulate the other ones. So there are a bunch of systems like that that have been developed.
I didn't mention it in my talk because I didn't have time to, but when I was first looking at my presentation, I was going to talk about bales and the variety of bales, and huge rectangular bales have been used for wineries because the temperature inside a 4-foot thick straw bale wall stays pretty nice, pretty level. The big round bales, they've been used actually for buildings. Some University of Arizona students years ago built a little building out at one of the university farm properties out of baled shredded paper. And it may still be out there. I visited a house in Colorado where the foundation was made out of huge blocks of plastic that they were going to, I'm not sure whether it was going to go to the landfill or where it was going to go, but they got these huge blocks, bales of crushed plastic, made the foundation out of that because those plastics are just very, very long lasting. Termites don't eat them. They don't care about moisture. And then on top of that plastic bale foundation, they built with baled cardboard. And again, these were huge bales that, you know.
You need a forklift.
Yeah, you practically need a forklift to put them in. But they did a very interesting house. It was up in Colorado. So David and I have both maybe in the same place seen privacy wall that was being built out of baled pinto bean stalks. You know, and we used to joke that if you can bale it, we can build with it.
Right. If you picked up those bales and you dropped them on the ground and then you pick it up, there were pinto beans on the ground. So
Don't let the wall get wet.
So we can say, if you can bale it, we will build it, right? A lot of interesting materials that seem to be ways to keep things out of landfills, and maybe that's good.
yeah, there's also a huge range of, there's great work being done in finding ways to reduce the impact of Portland cement, you know, and concrete to develop all kinds of different materials that it's really encouraging. I would say in the last 2 or 3 years, it's about a 10-fold increase in the amount of innovation and sort of exploration into this realm, which we sorely need.